none, and that's not going to affect the problem. 2x squared plus 4x plus 0, that doesn't affect the problem. And 0x squared plus 13x plus 3. Now, some of you might be asking, can't we do this vertically? You certainly can. You can stretch these out and just be sure that you find like terms. Does anyone remember what a like term is? Yes, I heard you. A like term is when you have a common variable with a common exponent. It has to be the same. So we need to look for like terms when you're adding or subtracting. Okay? So the first thing we're going to do, negative 6 plus 3 is negative 3. 0 plus 4 plus 13, oops, negative 13. Should be negative 9x. 4x squared plus 2x squared plus 0x squared is 6x squared. Now the second part of it, once we add up to find the mean, now we have to what? Divide by 3. So there's division by 3. Now you have to be careful because it has to go to every one of the terms. You have to think of this, I mentioned this yesterday, you got to think of this kind of like a little family. And you're going to divide the family up, you got to divide everybody in the family. You can't just take it to 1. So this really means 6x squared divided by 3 plus negative 9x divided by 3 plus negative 3 divided by 3. And you don't have to write out that next step. I just want you to kind of visualize what's going on. All right, so if we do this division, 3 goes into 6, divides into 6, 2x squared times, plus negative 9x divided by 3 would be negative 3x, and 3 divides into negative 3, negative 1. That certainly isn't the form we'd like to leave it in. 2x squared minus 3x minus 1. Now if we look at our answers, all the answers on the EOC are going to be multiple choice. So when you first look at this, notice a lot of the numbers are very similar. You're going to have to be very careful when you're looking for your answer that you keep track of the signs and you keep track of the coefficients, that you're not playing hocus pocus with your eyes. The one that we're looking for is answer C, and that one matched up perfectly. If you got stuck on this, what could you do to get yourself out of trouble? Well, what's the reverse of finding the average? You could go back and multiply, okay? We're going to talk about some of the strategies for finding multiple choice answers and how to eliminate some of these answers. Already, just looking at what we had 3 terms. There's only 2 of them that have 3 terms. Focus in on part C, okay? All right. Do we have any problems? Yes, we do. Katrina. Katrina from Nightdale from Conroy's class. Algebra 1, we're going to look at problem 7. Okay. Let me flip open to my notes. All right, problem 7. Suppose you take 100 units of medication for a cold that is eliminated by your system at a rate of 30% per hour. Assume you do not take additional doses. How many hours will it take for your body to have less than 10 units of medication in it? Well, logically, just thinking about this, my guess is that solution A is probably already out. It should take a little bit longer for that medication to go through you, even if you just read the back of a bottle that says always repeat your medication 4 to 6 hours. So my guess is that, but we're going to look at these numbers and see what works out as we go through the problem. Now, the other thing you need to be very careful of is that you don't assume that this is just a simple interest problem. Or a simple percent problem. This is happening every hour, so you can't just take one percentage. We're going to have to do several percentages over time on this one. All right, so the first one, if I organize some of the information, we have 100 units, and that basically, I'll say, is at 0 hours when we started. We started our clock at 0. Then I'm going to take 30% of 100. 30% of the 100 units we have, because that's how much is going to be gone at that first hour. So if I take 30% of 100, that leaves me with 70. Or actually, I'm sorry, that leaves me with 30. Subtract it from the 100. Leaves me with 70 units at 1 hour. Okay? Now there's 70 units in my body. So now I'm going to take 30% of 70. 30% of 70 is 21. So now I'm going to take the value that I had, 70 minus 21, and that's going to leave me with 49. That's at the second hour. Okay? We're going to keep going because what was our criteria? We wanted to know when we had less than 10 units of medication in our body. So this is not difficult. It might seem a little tedious to go through it, but this is a very simple way to handle this problem. So we're going to do 30% of what's left in our body, 49, which is 14.9. So 49 minus 14.9 is going to give us 34.1. That's at, oops, hold on. That's at our third hour. Not there yet. 30% of 34.1 is equal to 10.23. And we subtract that. And we're left with 23.87. That's at the fourth hour. Still not there. We have to get down to 10. Continue the process. 30% of 23.87 is equal to 7.161. Subtract that. And we're left with 16.709. Now, I did all this on the calculator, and I've done this arithmetic off to the side, so I know you can do this in your head, but use your calculator to get those numbers exact. All right, I'm almost to 10. I'm getting close. The medicine must be about to wear off. So 30% of 16.709 is equal to 5.0127. Subtract that. It looks close. Looks like we might make it. It's equal to, no, 11.6963. And that's at the sixth hour. So the next one must take us there. 30% of 11.6963 is equal to 3.50889. And if we subtract that out, I'm trying to squish this on the screen for you, we're equal to 8.18741, which of course we can round, and that's at when? At the seventh hour. Okay? So this is what we're looking for. So if we look at our answers over here, when does our body have less than 10 units? We were really close at the sixth hour. Don't get caught up. We have 7 as one of our choices. 5 was a choice. We're not quite there. That's the 16. And 9, well, if we kept going, there probably wouldn't be much left in our body at all by the 9. So choice B, 7. All right, Katrina, I hope that helps. Thank you. All right, we have a question from Matthew. Is it better to graph a problem or actually work out the problem when stuck? I guess it depends on the type of problem. If you can graph it, sometimes it really helps to visualize what's happening to the problem. We're going to get to a couple of them where I'm going to show you that there's some quick ways that you can do it by hand and quick ways that you can do it on the graph paper. Or not by hand on graph paper, or just to pop it onto the calculator and let the calculator take care of the math for you. Do you have a specific question you're looking at, Matthew? Can you call back and let me know? And I will help you out on that one. The graphing is definitely going to reinforce some of the algebra. So if you do get stuck algebraically, you just want to graph it, use the different features of the calculator. I'm going to review some of those with you as we go through this, and that'll help out. Okay? All right, thank you, Matthew. All right, Natasha from East Wake in Ray's class, Algebra 1, Problem 6. Let's look at that one. Problem 6. Linda is filing out her state income tax return. Her taxable income for the past year was $37,405. Nice job. According to the tax rate schedule, her tax is $765 plus 7% of the amount over $12,750. According to her W-2 form, she paid $2,517.91 in her state taxes. Determine the amount Linda owes or should be refunded. Well, I'm not sure about how many of you out there have actually filed your taxes, but I'm sure you've seen your parents stress out around April sometime. And what will happen is about a third of your paycheck, when you get it, if you look at those of you who started working, is given to Uncle Sam or it's given to the state of North Carolina. If you pay too much taxes by the end of the year, you're going to get a refund. If you don't pay enough, you're going to have to owe Uncle Sam a little bit more. So what we need to determine is based on, and they have tax tables, and of course the computers do a lot of it now, but we're going to work this one very simply out by hand on how much money she may or may not owe. Okay? So the first thing, we need to get some of our information organized. And I know it's in the problem, but there's an awful lot of words going on in this problem, and that's oftentimes what scares you, is all the words. It's just break it down to the math. So I'm going to pull out some of the important information. So the income, her income was $37,405, okay? And it said that the tax was equal to $765 plus 7% over $12,750. Well, how much more money did she make over 12,750? Okay, so this is almost a little tiny problem in and itself. So that's 765 plus, well, 7% of what's 37,405 minus 12,750. Okay, so you have to figure out what exactly, Natasha, the money that's being taxed at the 7%. So 765 plus the 7% of 24,655. And if we work that out, that's $765 plus 17,000, or I'm sorry, oh, that'd be a lot, $1,725.85. So all total tax for the money over the 12,000 is $1,725.85 plus that flat amount of $765. So her total tax is $2,490.85. Okay, that's her plasma TV gone right there. Okay, so on her W-2, which is the form that your boss will send you that says how much tax came out, and we'll go to Uncle Sam so you can't pretend you didn't pay it. On the W-2, it said that she paid $2,517.91, okay, to the state of North Carolina, because this was her state income tax, okay? She owes how much? She owes $490.85 to North Carolina. Well, she paid that, right? So if we subtract those two numbers, we're left with $27.06. So did she pay enough or not enough? Well, she only owes about $2,400, and she paid over $2,500. So she's going to get a refund. How much? Of $27.06. So the tricky part on this one, aside from making sure that you do a little mini problem within the whole problem, is looking at your answers. Linda still owes $2,490. She receives a refund of $2,490.85. Still owes $27.06. Receives a refund of $27.06. Where is this number $2490.85 coming from? Well, that came from the first part of our problem. Sometimes you're going to be so excited that you got an answer that matched. You're like, oh, it's A! And you're going to bubble A, and you're not going to move on. You need to come back to the problem and make sure you're answering. Determine the amount Linda owes or should be refunded. This was her tax. So see how, oh, you can't see it. This is the number that I came up with halfway through the problem. See how I labeled it was the tax? Down here is where I'm talking about the refund and the amount owed. So take that little bit of time to write down some words and get your information organized. Otherwise, you're going to end up bubbling A or B, and it's not even the right question yet. Okay? All right, Natasha, I hope that helped. And I hope you don't owe that much taxes this year. Hope I don't owe that much taxes this year. Forget that. All right, are there any other questions? All right, Marcus from East Wake in Staples class. We're going to do Algebra 1, Problem 4. Okay? All right, Marcus. Problem 4. Let's look at this one. 2x squared plus bx plus 5 factors into the form 2x plus f times x plus h, where f and h are integers. Find all the values of b if b is an integer. Okay, looking at our answers down here, it looks like there's an awful lot of combinations. We have to be sure that we understand what the problem is doing. Okay, first thing, the 2x squared plus mystery number bx plus 15. This is a quadratic. Quadratic is going to factor into what? Two factors in this case. They've already given us part of the factors, so we don't have to stress about some of our numbers. Where f and h, so our mystery numbers that we're trying to find, are integers. What's an integer? What's an integer? Think, think, think. You have your natural numbers. You naturally count 0, no, 1, 2, 3. Then you add the whole numbers. We pop in 0 into that set of natural numbers. And then what's missing? They're opposites at that point. So the integers are the whole numbers, 1, 2, 3, 4, 5, and 0, plus their opposites, negative 1, negative 2, negative 3, negative 4. No fractions, no decimals. So instantly looking at that, if they're not supposed to be fractions and decimals, can't we eliminate problem A and problem C, or answer A and answer C? They're gone. We can eliminate those right away because those answers have fractions in it, and it said that they had to be integers. So we know it's going to fall between B and D. So if you're running out of time and you don't know what to do, if you have to make an educated guess, you have no clue how to handle this problem, the worst case scenario, at least pick B and D, because you can narrow it down just based on the vocabulary. Okay. All right. Let's look to see how we'd solve this one, Marcus. Oh, too much paper. The original problem was 2x squared plus bx plus 15 factors into, remember how you open up those parentheses? There's a lot of different ways you can factor. 2x plus f and x plus h. Okay? So if we were to take this and FOIL this back, remember, multiply the first, outer, inner terms, we're going to get some of our possible combinations. The question is what could possibly go in for f and h? Well, when you're factoring, you have to take, when you're factoring, you want to take the multiples of 2 and the multiples of 15, and some combinations of those are going to give us our mystery number b. Now, the nice part about this one is they haven't, when you normally do a factoring problem, they limit you on what b can be, so there's only one possible answer. Well, in this one, they don't want one possible answer. Find all possible values. Okay? So, the way I set this one up, and I actually did this more guess and check just so I could organize my information. I have 2x plus some possible number can go there, times x plus some possible number can go there. And our quest is to figure out what those possible numbers could be. Well, what are the factors of 15? Are the factors that will multiply when we multiply f and h, whatever the mystery f and h are, that will give us positive 15. That's the very last part of FOIL, last, right? Okay, so what numbers will multiply to give us 15? Well, 15 times 1 will multiply to give us 15. 2x plus some mystery number, x plus mystery number. What's another combination? Well, 3 times 5, that'll give us 15. 2x plus some mystery number, x plus some mystery number. What's another possible combination? Don't forget your negatives. Negative 15 and negative 1, okay? Mystery number 2x plus a mystery number times x plus the other mystery number. What could that be? Negative 3 and negative 5. Is that all of them? I'll tell you what. When you're multiplying with these factors, the fact that we do know that 15 times 1 is the same as 1 times 15, but when you're doing the FOIL method, you actually work out with different answers. And I'm going to actually work these out so you can see it. So we need to take all of these combinations and reverse them. Put the 1 with the 2x and the 15 with the x now so that we have all possible combinations. So let me do that for you real quick and show you what I'm doing. So mystery number, and so that'll be 1 and 15. I'm going to switch those top ones. 2x plus that mystery number, and I'm going to switch these two to 5 and 3, and then we can't forget the negatives of those combinations. Now, this is taking a lot longer because I'm explaining, but when you're doing this on your test, it won't take you that long once you realize that you have to look for all the patterns. And that's the trick. Some of these problems, there's an infinite number of possibilities for questions that could be out there. So I need to give you some clues on what you could be looking for and how you might approach some of these problems, even if this, of course, this problem won't appear. Okay? All right, so now what are we going to do? We're going to FOIL. Well, the first term is always going to work out to be the same for all of them. It's going to be 2x squared. Okay? So I don't even have to worry about that one. Which term am I worried about? I'm worried about what is b going to be. These last terms are all going to multiply to give you what? They're going to multiply to give you 15. So I don't have to worry about the last term. I'm just going to write all those down so they're out of the way. In fact, probably on the test, I would have just written a line, but that's okay. Right? We have it all outlined and organized. So now what am I worried about? And I'm just a quick reminder, if we're doing the FOIL method, that means multiply the first terms. That's what this one is. L was the last terms. That's what the 15 is. Now we have to multiply the outer terms and the inner terms. So that means 2x times the 1 and the 15 times the x. So 15x plus 2x, that's an inner term. On this one, if we do it, we're going to get 3x and 10x. Multiply these inner terms, we're going to get negative 15x and negative 2x. Okay, I'm just going through and doing the multiplication. Multiply the next set, we're going to get negative 3x and negative 10x. Okay, 2 times negative 5 is negative 10x. Negative 3 times x is negative 3x. All right, so I'm just going to continue this FOIL method all the way down. So positive 1x plus 30. You don't have to put the 1, but it helps remind me what I'm doing. Positive 5x plus 6x. Negative 1x minus 30x. And finally, negative 5x minus 6x. And then all of these we knew were add 15. And that's a pretty cheaty way to do all that. But what I'm really concerned about are these inner terms right here. Okay? If we add up these terms, these are like terms. If we add them up, we're going to get that bx value. So 15x plus 2x is 17x. Okay? So I'm just going to take this piece right here. Let me change colors. Hopefully you can see the different colors. I'm going to take this piece right here and put the answers right here. So 15x plus 2x is 17x. 3x, oops, typo, plus 10x, otherwise they would be like terms, is 13x. Negative 15 and negative 2x would be negative 17x. Negative 3 and negative 10 would be negative 13x. 1 plus 30 would be 31x. 15x and 6x would be 11x. Negative 1 plus negative 30, would be 31x, negative 31x. And finally, negative 5 and negative 6 and negative 11x. So what are our possibilities for B? Well, look, you've got positive 11 and negative 11. You have positive 13 and negative 13. You have positive 17 and negative 17. And positive 31 and negative 31. Has that worked out to be one of our eliminated answers? Sure enough. Works out to be B. What's happening with this with D? Why isn't D working out to be correct? Well, that was one of the factors of our first term. That wasn't getting us where we needed to be. So be very, very careful that you work out all of them. You might have stopped and said, oh, I've got the 13 and the 15 and the 17. I must be done. Nope. Take a second. Just finish it off. Okay? All right. That was Marcus, right? So I hope that helps. And it won't take you that long to do it on paper now that you know how to do it. Okay? All right. Any other questions? Matthew from East Wake in Chickenelli's class. Algebra 2, problem 7. All right. So the goal we're working on right now, we're in Algebra 2. We flipped over to Algebra 2. So Algebra 2 people, focus. Algebra 1 people, this is what's coming in your future, geometry, next year. All right, operate with matrices to model and solve problems. Problem 7. Matrix T below shows the number of employees in thousands in several areas of transportation industry by columns, air, water, truck, and ground for 1998 and 1999. Matrix P shows the average annual salary for the employees in each transportation area by rows, air, water, truck, and ground. Passenger, find TP, meaning T times P, and define the elements. Okay? I'm not going to write on my original, but I'm going to rewrite it, and I would want you to define it so you can understand what you need to do. So this first matrix represents what? It represents air. It represented water. Oh, don't write on that one. You all didn't see that. I have to have a separate piece of paper here so I don't go through on the overhead. Or actually, it's called an Elmo. So let me try that again. So we have air, water, the truck company, let's put truck, and the ground passengers. Okay? And in our matrix, if I've gotten it big enough, it's going to be from 1998 to 1999. Those were our other two values. And this is just going to help me get focused on, because at the very end it asked me to define what the elements were, so I have to understand what it is I'm working with. So if I put in my numbers, 5,600, and I'm just rewriting that matrix that's on your paper right now. 728, 72.8, 71.8, 1,327.1, 13,842, hope you can read this, and 349.3, 3,700. Okay? And I think if I double check my numbers, I should have a decimal point. I've blown this up, but you be very careful when you write these or you're typing these in the calculator to get all your decimals straight. So 560.0, 72, 349, and 58, 2.8. Right? Okay. All right, so it never hurts to double check. Next thing is I want to multiply that times P. Now, this is my original P, and I'm see if we can squish it on here. I'm not going to do this one by hand. I know that you can do matrix multiplication by hand, but we're not going to do this one by hand, okay? But I need to see if I can get this in here. So this one is 41131.96, 4248, no, 42484.09, 3121.8.12. Thank you for being patient. And what did these represent? These represented air again, looks familiar, water, truck, and ground passengers. Now, they want us to multiply this. The first thing you need to determine is that even possible? I wouldn't be surprised on the EOC if they put an answer there that says not possible. How would you know if you can or cannot multiply a matrix? Well, the dimensions of this first matrix is a 2 by 4. Matrix of the second matrix is a 4 by 1. How do we know we can multiply those? If these inner values match, you'll be able to multiply it. What will your final matrix be? Your final matrix will be these outer values. So when you're looking for your answers, it should work out to be a 2 by 1 matrix. Look at your answers. Maybe that's the only one that's there, and you can check it and not even go on with the rest of the work. Okay, so I don't have multiple choice answers here to show you, but look for some of the patterns so you don't have to necessarily do the entire problem, okay? Not that I wouldn't want you to. All right, so if we type this into the calculator, so now you're going to have to be patient as I put it back in. I'm not going to put the whole thing in. I'm going to give you the answers. I just want to be sure that you all know how to set up a matrix on the calculator, okay? So I'm going to switch over to the calculator and turn it on. Actually, I lied. I'm going to switch back. On your calculator, which I hope everyone has a TI-83 or a TI-84 of some sort, the Plus, Silver Edition, it doesn't matter, but be sure you have a graphing calculator. If you want to have another little calculator that does fractions very pretty or percents very pretty, like a $10 one that you can get at the store or in a cereal box nowadays, it seems like, go ahead and have another one. That's okay, but be sure you have a graphing one for the Algebra 1. Geometry, you don't necessarily need it, but it'll be helpful in Algebra 2. You get one, okay? So right here above the, go down from second, right here above the inverse x -1, that button, there's your matrix. Type in your matrix. When your calculators have been cleared, there won't be anything there, but you have to go over to edit, then go down to the matrix you want to complete. Now I have one that's already in there. It's not going to hurt it. You put in the dimensions first, which is 2 by 4, okay? Now I'm going to switch over so that you all can see it clearly on the calculator. But just be careful that when you're typing it in, you type in the exact numbers that you need. Okay, let me flip over. So you should be seeing a calculator on the screen now. So what did I say this was? I said this was a 2 by 4 matrix. What if you weren't sure what the dimensions are? What if you typed in 2 or 4 by 2? Well, if you look at the way the elements have shown up, you have 2 columns and 4 rows, and that doesn't look like the matrix that you wrote down, so you know you just have to backtrack and put it in. Nobody's watching you. You're watching me, but I can't see what you're doing. So 2 and 4. And then when you type in your values, again, I'm not going to type everything in for you right now. But enter is going to take you across. Oh, maybe I will. See how much faster this is than even when I wrote it down? 582.8. 71.138.4.2 and 370. Okay. Oops, what did I do? I stopped looking. Five 5.82, 71.8, 138. 4.2. There we go. Don't panic if something goes wrong. Just look back over your matrix, okay? Now, once you're in this, you need to quit so you can put in the second matrix. So second quit, then go back to matrix. I am just going to go ahead and finish this off for you. So we're going to edit. We're going to edit matrix B. Now, what did I say matrix B? Matrix B was a 4 by 1. And those were those salaries, if you recall. 41131.96. I'm certainly not saying that very math correct, am I? 42484.09, 3121.8.12, and 1770.14. Okay? So I have my 2 matrices in there. What are we going to do? We're going to multiply. So I quit, and I have to bring up the matrix to multiply. So second matrix. Now it's under names. It's flashing under names. See if I move over, I'm under edit, math, edit, back to name, so hit enter, puts the A on the screen, times, second matrix again, go down to B, matrix B, hit enter, and there's our answer. So 73,745,951 cents and 76,765,958. Oops, wait, 76,790,637 and 45 cents. Don't want to forget those pennies. Now, what does that represent? Well, that represents the total salaries in 1998 and 1999 of all the employees. Now, I wanted to show you something. What if you had typed this in backwards? What if you had put let me go back to my screen. What if you had put this matrix of their salaries in for the A matrix and the matrix of the people who are working in for the B, or you just, when you typed it into the calculator, you switched it? That happens sometimes. Okay, I want to show you what's going to happen on your calculator. So second matrix, what if I take B and multiply it times matrix A? Okay, back over to my board over here. So that means I'm taking a 4 by 1 and trying to multiply it by a 2 by 4. Now, because you know matrices, you know that's not going to be legal, but I want you to see on the calculator when that happens, error, dim, mismatch, error, error, okay? Something's wrong. Something's wrong with the way it's matched up. And in our case, what's wrong is you can't multiply a 4 by 1 by a 2 by 4. So commutative property doesn't work for matrices in this case, right? So you have to be sure that you're doing it in the right order. So be very, very careful of that. Geometry people, that's a quick reminder to you because you're going to have to do some transformations out there with the matrices, and you have to be sure that you do those transformations in the right order as well, or they're not going to work. Okay? All right, so who's that? That was Matthew. So I hope that helps you out, Matthew. All right, thank you. Robert from Nightdale and Henke's class, is that right? Algebra 1, problem 3. Let's look at that. All right, this problem says, oops, I guess I don't need to keep your name up there, do I? If 5 to the x power times 5 to the x plus 3 power equals 5 to the 17th, then what is the value of x? Basically, what is that exponent? I'm going to show you mathematically how to do it, but let's pretend you have a complete panic attack and you're not quite sure what to do. Oh my gosh, I have no idea. I don't remember exponents. My teacher never taught them to me. I don't know. Relax, you can do it. So a lot of these problems, especially in Algebra 1 and Algebra 2, you're going to take the answers, and some math teachers are going to cringe when I say this, but plug and chug. Put it back into the problem, substitute in the values, type it into your calculator, and see. If I put 5 in for 5 to the 5th power times 5 to the 5 plus 3 power, which would be 8, does that work out to be 5 to the 17th power? Does it? Well, you have to remember some of your exponent rules to know that for sure, but by hand, but you could type that into your calculator to see. So let's just test the first one, shall we? Okay, I'm back to the calculator. So let me quit out of this. That was my error from the matrix. So if I took 5 to the 5th power times 5, don't forget those parentheses, oops, 5 raised to the, and I'm doing just a substitution, 5 plus 3 power, and enter it. Oh, that's not helping me. That doesn't look at all like the answer. Well, what's 5 to the 17th power? Don't panic. Do those numbers match? No. So that can't be the answer, can it? Okay? So that's just one method you can do if you forget. Now, I know you're not going to forget how to do exponents because we love exponents. But you certainly have a way to get yourself out of trouble. Okay? So the original problem, hold on, let me write it down, is 5 to the x times 5 to the x plus 3 equals 5 to the 17th, or does it equal? What does x have to equal to make that work? All right, so I showed you that you can plug and chug your values back in, substitute those values back in. The other choice is you just need to do the algebra with exponents. Well, what's the rule when you multiply exponents? If I had a to the n power times a to the m power, what's the rule? Well, the rule is, I don't remember the rule. Well, do one that you remember. Do something like x squared times x to the 3rd. What does that equal to? I still don't remember. Well, that means x times x times x times x times x, which is x to the 5th. Oh, what's the rule? I add. So when you multiply exponents, if they have the common base, you're going to add the exponents. Take a second to make the problem look simpler so you can remember what to do. What's the rule? Common base, 5 and 5, that's a common base. Add the exponents. So our left side of our equation is going to be 5 to the x plus 3. Should be equal to 5 to the 17th. Now what do I do? Well, you have x plus 3 should somehow equal 17 if this is going to work. So we're just going to do a little mini problem with just the exponents. X plus 3 should equal 17, and solve for what x should be. So 2x plus 3 equals 17. We're going to subtract 3 from both sides. 2x equals 14. We're going to divide both sides by 2. X equals 7. Is that one of our choices? Sure is. How can we check our work? You could type it back into your calculator. Now, I don't know if you all know this or not. Hopefully you do. I've learned all kinds of things about my calculator this past year. Down here, above the enter key is your entry button. So I've already typed in the problem up here with a 3. What you could do is hit second entry. I hit it the first time. Wait, let me go to the calculator. Hit it the first time, it gave me the last problem I typed in, which was 5 to the 17th. If I hit second enter again, look at that. It gives me the problem 2 back that I just did. So the nice part about that is I can just backtrack instead of having to type it in. This is really nice. Oh, and I just changed everything. Hold on. I went back too far. Oh, see, I messed it up, didn't I? Let me find it. See, those are all the problems that I've been typing in over the past 24 hours. There it is. Okay? So I can just backtrack and put in the 7 to check my work. So 5 to the 7th power. 7 plus 3, enter. And was that really equal to 5 to the 17th? Sure was. Okay? So just another way you can check yourself very quickly. All right. All right, Robert, I hope that helped out. Thank you. Algebra 1. Barbara from East Wake in Sutton's class. We're going to do Algebra 1, Problem 8. Thank you for calling, Barbara. All right, let's see. This is goal 1.03. Model and solve problems using direct variation. Oh, goodness. Okay. So, problem 8. The profit at a video arcade are directly proportional to the number of machines. If a profit of $700,000 was made with 150 machines, how much profit would be expected if the number of game machines dropped to 45? Directly proportional. As one thing happens, something else happens. Okay? They happen proportionally to each other. So where have you seen that before? Maybe with x and y, when you did linear graphs. One goes up, the other one goes up, one goes down, the other one goes down. Let's look at this. We have 150, x equals 700,000. What is that representing? Well, in here, I have 150 machines with some mystery profit equals $700,000. I just don't know what that mystery profit is, okay, per machine. So I'm going to set this up, divide by 150 on both sides, and I get x equals $4,666.66 repeating. So I'm just going to keep it the answer very exact right now and say 2/3, okay? You can leave the value in your calculator so you don't have to keep retyping it. So that's one choice. All right, so now we know how much the profit is per machine. So the question is what happens if the game machines drop to 45 machines? You don't have 150 machines now. They all broke. They got stolen. They fell down. Who knows what happened to them? You only have 45. So now how much money is going to be out there? Well, 45x, well, what's our x now? 4,666 to the 2/3 there equals our new value, our new mystery profit, okay, which before was $700,000. Now if we type that in, I get $210,000 equals our new profit, or y is our profit. Look at that. And don't get scared with all these decimals. Sometimes you're going to look at that and mix up decimals with commas. Just take your time and look at the answers. Now, do you see any other numbers up here that look familiar? Yes, look at D. D was $4,666.67. If I took that 2/3 and rounded it, that would be the 67 cents. Again, you're going to be so excited that you found something that matched. You're going to bubble in D. Don't. Take 1 second. Before you bubble anything, go back and see if you actually answered the question. Okay? All right. Thank you, Barbara. Rita from Nightdale. in Bonner's class is called with an Algebra 1 question, problem 5. Okay. Use formulas and algebraic expressions, including iterative and recursive forms, to model and solve problems. The simple interest formula for calculating a bank balance, back to money, is B sub n plus 1 plus equals 1 plus r times B sub n, where B sub n is the beginning balance and B sub n plus 1 is the balance at the end of the period, and r is the interest rate for that period. How much money would be in the new account after 1 year, B sub 1, if the annual interest rate is 5% and the principal, B sub 0, is 1,000? Oh my goodness, you're going to have to read this twice, okay? You're going to have to look at this and try to figure out what it is they're telling you. So what do you need to do? You need to organize it. Get rid of some of these words, and let's just organize our information, okay? So let me find my notes real quick. That's okay. All right, so the first thing is Algebra 1. There we go. I just want to be sure I have everything out in front of you. So for Algebra 1, oops, I almost wrote on my magic overhead again. First piece of information I want to organize is our first year, if you will. So B sub 1 is equal to 1 plus r times B sub 0. You have to get your first year organized, okay? B sub 0 was the money that you started with. Here we go. B sub 0 was the money that you started with at $1,000. We have to start somewhere. So the beginning is always 0. I did a problem a second ago where you took some medicine. That medicine was hour 0. You have to start somewhere, okay? So what is B sub 1? How much money are we going to have? So that's what we're solving for. B sub 1, which is year 1. 1 plus, and it was at 5%. So 5%. You can type in 5% if your calculator has a percent key, if you're using a different calculator, or change the percent to a decimal. I guarantee that's where some of your careless errors are going to come from, is just making simple algebra or arithmetic conversions. I did that yesterday, as a matter of fact, if you were watching, times 1,000. We multiply that out, we get B1, or B sub 1, which is year 1, is $1,050. Oh, look, it's there, bubble. No, look. I cannot say this enough times. How much money was in the new account? After the first year, yes, but part B, oh, look. Now they want the second year, okay? So this is a 4-part question. And you probably won't have a 4-part question necessarily broken up like this on the EOC, but the final question on the EOC might be, what is it after the 4th year? And I guarantee 1050 will be one of the choices. In fact, every year will probably be one of the choices, because they're going to watch for you to be stopping the problem too early or going too far, okay? So for part A, this does work out, 1050, so this is D. But we're not done, because now we have to do part B, which says, suppose you left the balance in the account, what's the new amount after the second year? All right, get organized. The second year is equal to 1 plus the interest rate times the first year's balance. Well, do we know the first year's balance? Yes, we do, grasshopper, right there. So B sub 2 equals 1 plus r times 1,050. You know what? I probably should have changed colors just so you could see the different times happening. I'll just group it so you can see, okay? All right, I'm going to keep going in green for the second year. So B sub 2 equals, again, 1 plus 0.05, and you can just keep that constant there if you wanted to instead of keep going, 1050. What is B sub 2? B sub 2 is equal to $1,102.50. $1,102.50. Look, there it is, okay? Part C. What is it the third year? And then part D is, what is it the 4th year? So we're going to do this 2 more times to get each one of our years. Okay? It really, really helps if you would just organize what it is you're trying to say. The third year is equal to 1 plus the rate times the second year. Do we know the second year? Yes, we do. Okay? So the third year is equal to 1.05 times the second year, which is 110250. So the third year is equal to $1,157.63. There's a choice. So that was part D as well. And part C is, what is the 4th one? Move some of my paper down. Change colors, just so you can see it. So let's do, again, organize. B sub 4 equals 1 plus the interest rate times the third year. So what is my fourth year? Fourth year is equal to 1.05 times $1,157.63. Now, obviously, if I'm typing this into the calculator, I'm just going to have these numbers still sitting there. It's times 0.105 again, times 0.105 again, times 0.105 again. But you might want to write some of this down on paper each time you do it so you don't forget how many times you said times 0.105, 105, okay? So the fourth year is equal to $1,215.51, which I hope that's one of our answers. Sure enough, okay? So, moral to this story, be sure you answer the whole question and save your money, because look, after 4 years, you got more. All right, thank you, Rita. All right, let's see if we have any other questions out there. Whew, isn't this fun? It's a lot of problems. Some of you are going to be doing a lot of homework over the weekend, but it'll be good because you want to pass that EOC. Why? Because it's worth up to what, almost 25% of your grade, correct? That's a lot of your final grade, and you need to be able to pass this. I know you can do it. Okay. If for some reason you need some extra support on this, if you go to the website, there's a success series out there, which is a series of videos that'll also walk you through some extra help on how to do some of the algebra, geometry, and algebra 2. Okay. All right, we are going to do Jose from East Wake and Sutton's class, Algebra 1, Problem 5. So this is goal 2, Jose. The learner will describe geometric figures in the coordinate plane algebraically. Find the lengths and midpoints of segments to solve problems. We have parallelogram ABCD that has vertices 8, 9, 9, 3, 2, 5, 1, 11. What are the coordinates of the intersections of the diagonals? Well, I'll be honest. I love geometry, and you're going to be given graph paper. And I'm probably going to say something I shouldn't say, which is, if you think about it, do you really need to plot this out? Do you need to take the extra maybe 2 minutes it's going to take? And some of you, when you draw, you get real particular and you get caught up in the drawing. Do you really need to take that extra time to draw it out? I'll say yes and I'll say no. Let me show you what the no part is. Now, if you can't see it, I'm certainly going to recommend that you put it on the paper. But if we have parallelogram ABCD, okay, wherever ABCD might be, oh, that's not a parallelogram at all. What's a parallelogram, geometry people? Quick, call in. Parallelogram has 5 major properties. Ready? Those of you know the dance. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. That was your musical interlude. Okay, so back to our parallelogram. So parallelogram is parallelogram ABCD. Okay, and it's asking us for the midpoints of the, oh, no, what's it asking us for? What are the coordinates of the intersections of the diagonals? So we are going to be trying to find the intersection of AC and BD. Now, those of you in Algebra 1 saying, oh, but I haven't had geometry, I don't know that. Yes, you do. Go back in some of your middle school. You learn some of these properties, then you know that these intersect. If in doubt, draw it out on the coordinate system. What you're looking for where these 2 points intersect is actually the midpoint of AC and the midpoint of BD. Okay? You can do this. So really, I don't have to draw this out on the coordinate system. I can just get visually that I want to find the midpoint of AC, and I want to find the midpoint of DB. And those should work out to be the same coordinate. Okay? So let's get organized. Our A was 8, 9. B was 9, 3. C was 2, 5. And D was 1, 11. Now, I'm a big believer in getting all your ingredients out and getting your recipe out before you start putting in values. Get everything organized, and then you can go ahead and start it. So these are our coordinates. We have to do midpoint. What is midpoint? What is midpoint? Midpoint, midpoint, middle, in the middle. So even if you can't remember the formula, just think it's the coordinate in the middle. How do you find the middle of 2 things? You take the average, the middle of 2 numbers, you take their average. So really we're going to be taking, to find midpoint, don't we take the sum of the x coordinates and divide by 2, and take the sum, hold on, sum of the y coordinates and divide by 2? We're taking the average of the coordinates. Okay, just think logically about what midpoint means. Don't try to get caught up with memorizing formulas. Same thing's going to happen when you have to learn your your volumes and surface area and all of that. Think about what it means, not some formula. All right, so the midpoint of AC. I'm right-handed. See my left hand? My left hand's not doing anything. So you know what? I'm going to use it to point. Am I doing this for your benefit? No, I'm doing this for my benefit because I've got a lot of stuff on the screen. Cover up and get organized with what you need because you don't need to make careless errors. So I need to take the average of the x's, so that's 8 and 2. So 8 plus 2 divided by 2, and 9 plus 5 divided by 2. Well, you know what 8 plus 2? 8 plus 2 is 10. Well, you know what? More careless errors are going to come because you're trying to do two things at once. If I just put down 10 over 2, 95% of you will get it right. That's fine, no problem. What's going to happen is I'm busy doing the midpoint formula and I'm busy doing arithmetic. Just do one thing at a time. It really doesn't take that much longer. In fact, if you look at all the characters here, there's probably aren't the same number of characters that are even in my name. And I can write my name pretty fast, right? The only reason this is taking a while is because I'm talking. So 9 plus 5 is 14 halves. Reduce it, so that would be the 0.57. Now, I really shouldn't have to go any further because I know that the midpoint is it, but how can I check my work? We're going to find dB, and we'll be able to do that real quickly now because everything's set up. We have all our ingredients out. So 9 plus 1 divided by 2 is the x-coordinates. 3 plus 11 divided by 2 is our y-coordinates. That works out to be 10 halves and 14 halves, which again is 5, 7. There we go. Now, 5, 7 is B. If you wanted to put this on the coordinate system, on the graph paper, and you plotted these 4 points out there as well, I bet you only one of them is even really close, okay? So if you forget how to do midpoint, which I know you're not going to do, but if you forget how to do midpoint, you want to put it on the coordinate system, just take and plot the answers, and maybe you could eliminate it maybe down to A and B because they're really close, or B and C because they're really close, and that'll help you narrow down some of your answers. So I didn't draw this problem out, but you certainly can. You just have to get organized on what you need. All right, Jose, I hope that helps you out. Oh, wait, there was a part B to it, wasn't there? Part B. Here we go. B is what is the perimeter? All right, so what is perimeter? Well, in general, what is perimeter, Jose? Well, perimeter means add up the values all the way around, okay? So if we're going to add up the values all the way around this figure, that means we have to find the length of what AD is and the length of BD, BC, and DC, okay? Length. What is length on the coordinate system? Length on the coordinate system is distance formula, okay? You're going to have to know the distance formula as well. All right, now, let me get another piece of paper up here. Let me leave my picture and my recipe and information. All right, so what is distance formula? Distance formula is equal to the square root, whoops, I'm off the screen, the square root of the change of the x-coordinates plus the change in the y-coordinates. That's not how I'm used to seeing. I'm used to seeing x1, y1, x2, y2. Well, what if you mix those up? So I'm trying to get you to understand that sometimes you just need to think about what the formula represents. So does this feel better? x2 minus x1 squared plus y2 minus y1 squared. Later on, you're going to learn that that's just part of the Pythagorean theorem when you get into geometry, okay? So that's our distance formula. So we're going to have to do that 4 times, right? No, think. It's a parallelogram. That means opposite sides are parallel. Opposite sides are congruent. Opposite sides are congruent, then that means they have the same length. They have the same length. We really need to do it twice. So I'm going to find the length of AB, which will also give me the length of DC. So I just have to remember to double it. So I'm going to put a little reminder off to the side to double it. This is my recipe. Plus, I have to find the length. I'm going to find the length of AD. And I'm going to remind myself that I need to double that. So there's my recipe. 2 times the length of AB plus 2 times the length of AD. I have some ingredients. Let's go to one mixing bowl and find AB, sorry. All right, so the change in the x coordinates plus the change in the y coordinates. Here's A and here's B. So again, I'm putting my fingers up here to remind you. To remind myself. Forget reminding you. I'm reminding myself. I'm trying to keep organized. So 3 minus 9 squared plus 9 minus 8 squared. Go ahead and simplify that out. 3 minus 9 is, oh, you know what? I did my y's first. It's not going to matter in this case because I've squared it, but I want to stick to the formula. Well, what happens when you do the y's first? You remember what that formula was? That was a slope when you do the y's first, so I apologize. All right, let's look at that again. So AB is equal to, let's try that again. So 9 minus, make sure I'm right now. Okay, 9 minus 8 squared plus 3 minus 9 squared. That's better. 9 minus 1 is 1 squared, plus 3 minus 9 is negative 6 squared. Work that out. Now, you can't just take the square root of two things squared and say it's 1 plus 6. That doesn't work, okay? So we have to add those together. So that's 1 plus, and I want to show you something on the calculator. This is very important, FYI, those of you who love to type things into your calculator. There's a difference to your calculator of negative 6 squared versus negative 6, dramatic pause, squared, okay? Flip over to the calculator real quick, and I'll show you. Turn it on. Let me clear off some of that stuff from before. If I type in negative 6 squared, ooh, negative 36. What if I type in parentheses negative 6 squared? Positive 36. Well, logically think this out. A number squared, whether it's positive or negative, a positive times a positive is positive, a negative times a negative is positive. So any number squared should be positive. But you know what? You're going to get, sometimes you get a little flustered when you're taking the test and you get very anxious, and you typed into that calculator negative 6 squared, and it gave you negative 36, and without even remembering and knowing it, you're going to write down that negative 36. So you either have to remember, one, a number squared is always positive, or on your calculator, be sure you put in those parentheses, okay? That's a very common error. All right, so 36, so the square root of 37. Square root of 37 is an exact answer. Now, if we look at what type of answers are coming up on for our choices, they're in radical form, which means they want exact answers. If they had had decimals here, then they want you to round the answers, in which case you could type into your calculator. So the square root of 37 is a valid number. Might not be a very pretty number, but it's a valid number, okay? And it's an exact number, very important. Geometry, I hope you're listening to. Exact number. All right, so there's AB. Now we have to find AD. And what was the recipe? Again, the change in x's over the change in y's. AD, this top and bottom, so square root of 8 plus 1 squared plus 9 plus 11 squared. Did I do that right? Minus, there we go. Got to follow the recipe. Change means subtraction. So let me write it real clear for you. 8 minus 1 squared plus 9 minus 11 squared, much better. 8 minus 1 is 7. So 7 squared plus 9 minus 11 is negative 3 squared. No, it's not. Negative 2. Whew, it's almost time to call it a day, isn't it? All right, so square of 7 would be 49 plus negative 2 squared is what? Always a positive, so in this case positive 4. So 53, square root of 53. All right, so now what? Well, our recipe said that it was 2 times AB, so 2 times radical 37 plus, I'm even on the screen here, sorry. 2 plus radical 37 plus 2 times AD, which was radical 53. Doesn't look like a pretty answer, but it is a valid answer. And if somebody really was cutting a piece of wood, you probably wouldn't say, oh, would you please cut my wood at 2 radical 37 plus 2 radical 53. But this is an exact answer. If we were doing laser eye surgery, would you want your optometrist to estimate what 2 radical 37 was for the laser? I don't think so. You might lose an eye or nose or wherever the laser ends up, right? So you want to be careful depending on the situation. This was just a general perimeter problem. Wasn't that necessary, I guess. But sometimes those exact answers are going to matter. So is that one of our choices? It sure is. Okay. All right. Thank you. All right, so that's all the time we have for today. I wanted to thank everybody for calling in, and I will be back on Wednesday if you have any other questions, and some of these will be replayed on the weekend. Look over the problems, practice. You're going to do great on the EOC. Thanks. Bye-bye.